At 22:27 hours on April 9, 1943, the War Patrol log recorded surface contact bearing green 30, range decreasing, course steady. The submarine was running at decks awash condition. Main ballast tanks were partially flooded. All watertight doors were secured. Ventilation remained open. Diesel engines were online at ordered revolutions. Battery charge was within operational limits. The control room reported trim acceptable fore and aft. Depth gauges were steady. Gyro compass repeaters were aligned and responding. The navigation plot was updated with incremental bearing changes. Radar operators logged intermittent returns at close range before shifting to visual observation only. No radio transmissions were made. On the bridge, blackout conditions were enforced. Lookouts were posted port and starboard with assigned arcs. Sea state was moderate with scattered rain squalls reducing horizon definition. Multiple silhouettes were visible ahead without classification entry. Running lights were not observed. No aircraft noise was reported. In the forward torpedo room, tubes 1 through 6 were reported ready. Firing circuits were tested and set. Gyro angles were entered and confirmed. Safety interlocks were verified. The after torpedo room reported stern tubes prepared for immediate use. Sound-powered telephone circuits were restricted to essential stations. Unnecessary machinery was secured. Engineering spaces reported all 4 engines answering bells and generator load stable. At 22:29, the deck log noted further reduction in range and ordered course maintained. The next scheduled entry time was recorded, with no additional notation entered at that moment. On March 18, 1943, the United States Fleet submarine USS Tunney, SS-282, under the command of Commander James Scott, departed Hawaiian waters after refitting support by tender and completion of a short period of training intended to restore readiness following earlier operations. The patrol orders in effect assigned the submarine to an operational area in the Central Pacific, with interim routing through Midway Island for material correction before proceeding to the first objective. The movement was executed under routine wartime procedures for independent submarines, navigation by dead reckoning and celestial fixes when conditions permitted, periodic course and speed changes as required for routing and for reduction of predictability, and shipboard control of emissions, including restricted use of lights and radio transmissions except when required by operational directives or safety of navigation. At Midway Island, the submarine conducted replacement of a periscope as a specific maintenance action recorded as necessary prior to the continuation of the patrol. The periscope replacement required the submarine to enter a controlled harbor environment under escort and harbor regulations, to moor in a designated berth or alongside support facilities, and to coordinate the work with base personnel and supporting units responsible for optical equipment. The completion of this work allowed the submarine to resume patrol operations with restored capability for visual observation and target identification at periscope depth, and for surface navigation in conditions where use of bridge lookouts alone was insufficient for early detection of hazards. Following the replacement, Tunney got underway for Wake Island on March 24, 1943. The transit to Wake Island was conducted with the submarine maintaining standard watch organization. The surface watch on the bridge consisted of an officer of the deck supported by lookouts assigned sectors, with continuous scanning for aircraft silhouettes, wakes, mastheads, and changes in horizon line that could indicate ships or land. Below decks, the ship maintained a conning officer and diving officer during evolutions requiring rapid changes in depth, with control room personnel stationed at depth gauges, trim manifold, and ballast and vent controls. The engineering plant was operated for sustained cruising, with diesel engines used to provide propulsion and to charge the main storage batteries while surfaced, submerged running, when required, depended on battery power and electric motors, with speed limitations imposed by endurance considerations and heat buildup. Torpedo rooms maintained a readiness posture in accordance with patrol standing orders, with warheads installed and safe/arm conditions controlled by procedural checks. On March 27, 1943, Tunney arrived off Wake Island and operated within a broad radius described as a 200 nautical mile circle through the day. The patrol profile in the vicinity of an enemy-held island required deliberate management of exposure, because shore-based aircraft and patrol craft could be launched with short notice and because the island itself could provide a reference point for enemy search patterns. When operating within approximately 30 nautical miles of Wake, the submarine flooded down to decks awash, a condition in which buoyancy was reduced so that the deck was near or at the waterline, presenting a smaller silhouette while still permitting air intake for diesels and limited surface speed. This procedure required careful control of ballast tank flooding and venting and continual attention to sea state, because waves could sweep the deck and impose risk of downflooding through openings if not properly secured. The approach was continued before dawn on the following morning, when Tunney closed to within roughly 10 miles of the island and observed lights ashore. In that pre-dawn period, a motor torpedo boat and 2 patrol boats passed within approximately 600 yards of the submarine without detecting it. Such a near passage, in the context of a submarine operating in reduced freeboard condition, required the bridge team to keep all unnecessary movement to a minimum, to avoid reflective surfaces, and to ensure that engine exhaust and visible wake were minimized by appropriate speed selection. The control room retained immediate readiness to submerge on order, with vents and main induction arranged for rapid closure, and with men stationed to secure topside openings. In this environment, the submarine's ability to remain undetected depended on sea conditions, the effectiveness and alertness of the enemy lookouts, and the submarine's discipline in maintaining a low profile. Trailing the small surface craft, Tunney encountered a cargo ship identified in the patrol narrative as Soa Maru and entered a battle stations posture. The order to man battle stations on a U.S. fleet submarine placed torpedo fire control parties, periscope operators, sonar and radar operators, and engineering watchstanders at full readiness. The forward torpedo room prepared tubes for firing, tube doors were checked, vents and drains aligned, and the torpedo impulse and gyro settings confirmed. In the control room, the torpedo data computer party, where equipped, or the plotting party on the attack periscope established target course, speed, and angle on the bow through visual observations and, at night or reduced visibility, radar inputs when permitted. The decision to attack with torpedoes required identification and evaluation of escort presence and an estimate of probability of counterattack if the submarine's position became known. During this sequence, the submarine launched torpedoes at a target described as Kozai Maru, an 8,000-ton passenger cargo ship, and recorded 2 hits, one amidships and one aft. Immediately after firing, Tunney executed a dive to evade the escort described as an Akatsuki-class destroyer patrolling ahead of the transport. Diving after firing was a standard measure intended to reduce the submarine's vulnerability to gunfire and to complicate the enemy's attempt to establish a reliable firing solution for depth charges. The dive required closure of the main induction, securing of the bridge and conning tower hatches, and management of down angle and speed to reach a chosen depth without excessive noise or loss of depth control. Once submerged, the submarine shifted to evasion procedures, which included minimizing machinery noise, reducing speed to limit propeller cavitation, and using course changes to avoid predictable patterns. A depth charge counterattack continued until the destroyer lost contact in a heavy rain squall. Tunney then withdrew from the immediate area. The patrol continued through early April with the submarine maneuvering among assigned sectors and transit routes consistent with intelligence reports of Japanese traffic. On April 8, 1943, Tunney surfaced in a downpour to continue patrols north of West Fiu Island. Surfacing in heavy rain served practical functions. It permitted battery charging, air ventilation, and higher transit speed while reducing the risk of visual detection by aircraft or distant surface lookouts due to lowered visibility. Surfaced operation required continuous air and surface search, with radar used when available and appropriate, and with lookout scanning for aircraft, mastheads, phosphorescent wakes, and changes in weather that could reveal or conceal the submarine. That same day, Tunney set course to intercept a convoy reported to be southwest of Truk. The interception task required the submarine to translate convoy reports into an estimated track and to position ahead of the formation for an attack. When convoy information was limited to approximate location and course, the submarine's navigation and plotting team constructed a search plan, establishing likely lanes based on known shipping routes, determining the submarine's best speed of advance under prevailing sea state, and managing battery capacity to ensure submerged attack capability at the expected contact time. The ship's radar, when used for surface search, provided an ability to detect formations beyond visual range at night or in rain, but radar employment carried risk if the enemy possessed radar detection capabilities or if emissions discipline was required by higher command. The patrol narrative records that at 22:28 on April 9 Tunney made radar contact with a formation less than 3 miles distant and went to 4 engines to maneuver into position. Going to 4 engines on a fleet submarine meant bringing all available diesel engines online to obtain maximum surface speed for maneuver. This evolution required coordination between the bridge and the engine rooms. The officer of the deck ordered the speed increase, engine room watchstanders answered bells, adjusted throttles, and monitored temperatures, pressures, and vibration. The electrical division monitored battery charging conditions and ensured that generator loads remained within limits. Increased speed also increased the submarine's wake and engine noise, which had to be balanced against the tactical necessity of reaching an advantageous firing position before the convoy could pass. The contact's change of course, described as occurring within minutes, placed Tunney in a position to slow to 2/3 speed and head in, flooding down to decks awash to avoid detection. The decks awash approach at night against a major formation was a deliberate tactic used to combine surface maneuverability with reduced silhouette. The boat's ballast control parties adjusted main ballast tank flooding to lower freeboard, while the bridge and control room coordinated to ensure that ventilation and engine intake remained adequate and that the boat maintained stability in the sea state. The conning tower watch controlled the profile of the submarine by restricting unnecessary lights and by maintaining a steady course to limit visible wake changes. The approach also required constant readiness for an emergency dive, because detection at close range could lead to immediate gunfire or ramming attempts. In the recorded account, as the formation became visible, Tunney's commanding officer observed on the starboard bow a large aircraft carrier, to port 2 auxiliary carriers, and on each bow of the formation a destroyer. The contact's composition indicated a screened high-value unit group rather than a merchant convoy, increasing both the potential value of an attack and the expected intensity of countermeasures if the submarine were detected. At this stage the submarine's internal organization shifted to maximize attack readiness while maintaining control of the ship in close proximity to enemy units. In the conning tower, the commanding officer and approach officer used visual bearings and range estimates supplemented by radar information as available. The fire control party prepared solutions for multiple targets, requiring rapid assessment of target courses and speeds and the relative motion between submarine and targets. Torpedo rooms prepared both bow and stern tubes for near-term firing, including checks of tube readiness lights, equalization of pressure, and confirmation of torpedo settings. The periscope was of limited use in decks awash surface approach. Instead, the attack depended on the bridge team's ability to maintain situational awareness and on the control room's ability to execute immediate depth changes if required. The account records that Tunney maneuvered to swing the bow on twin targets but that the plan was disrupted when 3 small boats, similar to motor torpedo boats, appeared only 300 yards off the port bow. At such distance, the time available for decision and execution was measured in seconds. Remaining on the surface at decks awash in close proximity to small craft carried a significant risk of collision, gunfire, or immediate alert of the larger formation. The submarine therefore executed a quick dive to 40 feet, turned right 90 degrees, and fired 4 torpedoes from stern tubes at one of the auxiliary carriers from a distance of 880 yards. The dive to 40 feet placed the boat shallow enough for rapid maneuver and periscope use while reducing vulnerability to surface gunfire. It also required careful depth control to avoid broaching, which could disclose the submarine's position. The stern tube firing required alignment of the submarine's stern on the target bearing. The control room coordinated rudder and engine orders while the after torpedo room executed firing sequence tube by tube. Torpedo firing at close range involved a controlled sequence. For each tube selected, the the torpedo room opened the outer door only after ensuring proper equalization, and then fired using either compressed air impulse or other firing mechanism depending on the boat's configuration and the standing procedures. Gyro angles were set according to the fire control solution to ensure the torpedoes run aligned with the predicted intercept point. The submarine's crew monitored sound and vibration in the hull as torpedoes left the tubes, and the attack team listened for explosions through hull conduction. In the narrative, 4 torpedo explosions were heard through the night as Tunney shifted attention to other targets. The heard explosions were recorded as part of the attack sequence without a claim in the same passage of confirmed sinking, reflecting the uncertainty inherent in combat observation under conditions of noise, darkness, and immediate evasion. Following the stern salvo, the submarine executed a transition to engage the large carrier. The account states that signaling from the new target provided the executive officer at the con a final check on the target's bearing and that Tunney released a salvo of 6 torpedoes from bow tubes at the large carrier. This required shifting the submarine's orientation so that bow tubes could be brought to bear, and it required the forward torpedo room to complete preparations for a multiple tube salvo. Bow salvo firing created a concentrated attack intended to overcome the defensive advantages of a screened carrier and to increase the chance of at least one effective hit. During the salvo, the control room maintained depth and heading stability sufficient to preserve the firing solution at the moment each torpedo was released. Immediately after completing the attack, Tunney dove in the presence of depth charges and churning screws, a description indicating the onset of escort reactions and high-speed maneuvering by surface ships in the area. Standard post-attack practice emphasized rapid withdrawal from the firing point, because escorts typically counterattacked the estimated launch position. The submarine's evasion depended on depth changes, course changes, and sound discipline. In the shallow to moderate depths common in many Central Pacific approaches, the submarine could not always go deep enough to escape detection by depth setting alone, and therefore relied on silent running measures to reduce the strength of sonar returns and to complicate the escort's tracking. These measures included stopping unnecessary machinery, securing ventilation fans where possible, reducing speed, and controlling the movement of personnel to prevent hull noise. The immediate acoustic environment after the attack was dominated by multiple surface screws and by detonations. In the submarine sound room, operators attempted to classify ship types by propeller signature and to determine relative bearings and ranges by hydrophone reception. In the control room, the diving officer maintained depth against the changing pressures created by depth charge detonations and by the submarine's own speed changes. The engineering plant shifted from diesel operation to battery electric propulsion, with the diesel engine secured and main induction closed prior to diving. Electrical watchstanders monitored battery discharge rate and motor load, ensuring that the speed selected for evasion did not deplete battery reserves needed for later operations. The patrol account records that the submarine then unobtrusively slipped away to the north, indicating that, in the immediate aftermath, the escort effort did not achieve a sustained, accurate track sufficient to bring the submarine under a prolonged, effective depth charge attack. The tactical outcome at this stage depended not on the number of detonations heard but on whether the escorts could maintain sonar contact through course reversals, thermal layers, and the interference produced by the movement of multiple ships in close formation. Submarine doctrine treated the first minutes after attack as critical. A boat that could exit the central area of the screen and widen lateral separation had a greater chance of breaking contact. The record of Tunney's withdrawal reflects that this separation was achieved during the period of noise and confusion immediately after the torpedo salvos. Within the submarine, the consequences of the attack and evasion phase required immediate administrative and technical actions. The control room recorded key times, courses, depths, and estimated positions for inclusion in the patrol log and eventual war patrol report. Torpedo room personnel verified remaining inventory, tube readiness, and the status of reloads, as applicable. Damage control parties conducted quick checks for leaks, flooding, or equipment displacement caused by nearby detonations. Communications personnel maintained radio silence unless a situation demanded immediate transmission, because the submarine's survival and the continuation of the patrol depended on remaining undisclosed. The medical department remained ready for treatment of injuries resulting from sudden depth changes or from shock effects, though the recorded narrative for this phase does not include injuries or structural damage. The operational situation after disengagement required the submarine to restore readiness for further contact while remaining cautious about the likelihood of enemy aircraft search at dawn and of surface pursuit by destroyers. The submarine's captain and senior officers assessed immediate priorities: whether to remain submerged through daylight to avoid air attack, whether to regain distance from the enemy formation before surfacing, and whether to attempt to recontact damaged units if the tactical and battery situation allowed. These decisions were constrained by battery state, because prolonged submerged maneuver at higher speeds could rapidly reduce endurance, and by the need to ventilate the boat and recharge batteries to sustain future operations. The narrative indicates that after the escape and subsequent maneuvering, an hour and 1/2 after midnight on April 10 the submarine surfaced and set her course to return to her patrol area. Following the disengagement from the enemy formation in the early hours of April 10, 1943 and prior to the subsequent resumption of routine patrol activities, USS Tunney entered a period characterized by controlled stabilization of shipboard conditions and systematic administrative follow-through. This interval, extending from the completion of immediate evasion measures until the confirmed restoration of normal patrol rhythm, was governed by established U.S. Navy submarine operating procedures intended to preserve material readiness and crew effectiveness after combat action. Once the submarine had achieved sufficient separation from the estimated enemy contact area, depth was adjusted incrementally to a level permitting controlled maneuver without risk of broaching or excessive hull stress. Speed was reduced to minimize battery expenditure and internal noise. The control room maintained continuous depth and trim monitoring, with periodic checks of bubble indicators and compensating tank levels to counter minor imbalances caused by crew movement, temperature changes, and battery discharge. Engineering spaces transitioned fully to submerged operating conditions. Diesel engines, already secured prior to the dive, were placed in a protected state, with fuel lines isolated and exhaust systems sealed. Electric motors assumed propulsion duties, operating at low revolutions. Engineering logs were updated to reflect the transition, noting time of diesel shutdown, battery condition, and motor load. Auxiliary machinery essential for submerged endurance, including air purification units and limited ventilation fans, was operated according to silent running guidelines. Damage control personnel conducted compartment-by-compartment inspections using portable lighting where required. These inspections focused on hull penetrations, valve packing, pipe joints, and equipment foundations known to be vulnerable to shock. Particular attention was given to forward and after torpedo rooms, where the firing of multiple tubes could contribute to mechanical strain. No leaks, structural deformation, or equipment displacement beyond normal tolerances were recorded. Results were entered into the damage control log and reported to the executive officer. In the torpedo rooms, post-firing procedures were carried out methodically. Fired tubes were drained, dried, and reset. Breech doors were inspected for proper seating, and firing circuits were checked for continuity. Remaining torpedoes were examined visually for signs of shock damage, and gyro settings were returned to neutral. Inventory counts were reconciled with the attack log, and preliminary expenditure figures were prepared for later inclusion in the formal War Patrol report. The fire control party reviewed plotted data from the engagement. Target bearings, estimated ranges, firing times, and gyro angles were transcribed from plotting sheets into permanent records. These documents were retained for later compilation and analysis upon return to port. No claims of confirmed sinkings were entered at this stage, in accordance with standing instructions requiring post-patrol verification. Communications personnel maintained strict radio silence. Incoming receivers were monitored intermittently for high-priority broadcasts, but no transmissions were acknowledged or initiated. Signal logs reflect only internal status entries during this period. Crew routine was gradually normalized once the immediate threat of counterattack was assessed as reduced. Watch rotations were adjusted to allow rest for personnel who had been continuously engaged during the attack and evasion phase. Meals were prepared under reduced lighting and noise restrictions. Galley operations were conducted using electric equipment only, with care taken to limit odors and sound transmission through the hull. Medical checks were informal and preventive in nature. The corpsman verified the condition of personnel who had been exposed to rapid depth changes or confined positions during the engagement. No injuries or cases of decompression-related symptoms were noted. Navigation updates were performed using accumulated dead reckoning data. The navigator recalculated the submarine's estimated position based on course and speed changes executed during evasion. These calculations were marked as approximate, reflecting the uncertainty inherent in high-speed maneuvering under combat conditions. Charts were updated accordingly, with intended future tracks penciled in but not finalized pending daylight assessment. Throughout this interval, the commanding officer conducted periodic reviews of the ship's status with senior enlisted and officer personnel, focusing on readiness rather than evaluation. Orders issued were procedural in nature, reinforcing adherence to patrol doctrine and emphasizing caution during the transition back to surface operations. This phase concluded when environmental and tactical conditions permitted surfacing for battery recharge and ventilation, at which point the submarine shifted from post-engagement stabilization to sustained patrol operations already documented in the subsequent record. After surfacing approximately 90 minutes after midnight on April 10, 1943, USS Tunney resumed surface navigation under conditions of reduced visibility and continued precipitation. The submarine's immediate post-engagement posture emphasized restoration of propulsion endurance and internal habitability. Diesel engines were brought online sequentially, with engineering watchstanders verifying lubrication oil pressure, cooling water flow, exhaust temperature, and generator load before advancing to sustained cruising revolutions. Battery charging commenced once electrical parameters stabilized, with the electrical officer monitoring charge rate to avoid overheating or excessive gassing. Ventilation systems were operated to remove accumulated humidity and exhaust residual odors from submerged operation, restoring acceptable air quality throughout the pressure hull. Surface watches were re-established in accordance with night steaming procedures. The officer of the deck maintained continuous radar and visual surveillance, supported by lookouts assigned overlapping sectors. Radar operation, when employed, was intermittent and controlled to reduce the probability of detection by enemy electronic countermeasures. Navigation fixes were updated using dead reckoning supplemented by celestial observations when cloud cover permitted brief star sightings. The submarine maintained radio silence, consistent with standing orders following an attack on major enemy units, and no immediate contact reports were transmitted during this period. Throughout the remainder of the night and into the early morning hours, no enemy aircraft or surface vessels were sighted. The absence of contact was noted in the deck log and war patrol record as a continuation of withdrawal from the engagement area. The submarine altered course incrementally to the north and northeast, increasing lateral separation from the estimated enemy formation track. Speed was adjusted to balance rapid clearance of the danger area against the need to conserve fuel and minimize wake visibility at dawn. At daylight on April 10, Tunney remained on the surface under overcast conditions with moderate seas. Morning routine aboard the submarine proceeded under wartime patrol constraints. Crew members not required for watch or engineering duties performed maintenance tasks, including inspection of valves and fittings affected by depth charge concussion, cleaning of machinery spaces, and servicing of weapons systems. Torpedo room personnel conducted inventory checks, verified the condition of remaining torpedoes, and documented expenditure from both bow and stern tubes in preparation for inclusion in the formal patrol report. No mechanical defects or flooding attributable to the previous night's engagement were recorded. The commanding officer directed the submarine to resume patrol in assigned waters, consistent with operational orders that emphasized continued interdiction of enemy naval forces. Intelligence available to the submarine at that time did not include confirmed results of the torpedo attack. The absence of such confirmation was consistent with standard wartime conditions, as submarines often lacked opportunity to observe damage directly or to remain in the vicinity long enough to assess outcomes without undue risk. During the 10th and the 11th of April, Tunney conducted routine patrol operations without contact. The submarine alternated between surface and submerged periods according to daylight, weather, and assessed threat level. Submerged operations during daylight hours followed standard silent running practices when operating in areas assessed as having potential enemy air coverage. The boat maintained depths appropriate to sea conditions and sonar performance, typically between periscope depth for brief observations and deeper running to reduce detection risk. Periscope exposures were limited in duration and frequency, with observations logged and cross-checked against navigation estimates. Engineering operations during this interval focused on maintaining propulsion reliability and battery readiness. Preventive maintenance was carried out on diesel engines, including inspection of injectors and exhaust manifolds, while submerged, auxiliary machinery such as air compressors and refrigeration units were operated intermittently to maintain essential services without excessive noise. The crew adhered to established noise discipline protocols, particularly during submerged daylight hours, to minimize the acoustic signature of the submarine. Administrative routines continued concurrently. The navigator refined position estimates using accumulated data, correcting for currents and leeway observed during the preceding days. The executive officer oversaw discipline, watch rotations, and the documentation of events in the ship's logs. The medical department monitored crew condition, with attention to fatigue following extended periods of high alert during the night engagement. No medical incidents were recorded during this phase. On April 12, 1943, the submarine received no new operational signals and remained under radio silence. The patrol area was described in the logs as quiet, with no merchant traffic observed and no indications of enemy search activity beyond routine distant aircraft sightings that did not approach within detection range. Weather conditions remained variable, with intermittent squalls and moderate winds, affecting visibility but not significantly altering patrol conduct. By mid-April, the commanding officer evaluated the patrol situation in light of torpedo inventory, fuel state, and the elapsed time since departure from Midway. While sufficient endurance remained for continued operations, the absence of contacts and the strategic value already derived from the earlier engagement were factors considered in subsequent routing decisions, which were constrained by orders and by the need to maintain readiness for further tasking. On April 14, Tunney altered course as directed by operational routing instructions received earlier in the patrol, proceeding toward a new sector within the broader assigned area. The movement was conducted at economical cruising speed on the surface during hours of darkness and submerged during daylight, following standard Pacific Fleet submarine doctrine. No deviations from planned track were recorded during this transit. Throughout the 15th and the 16th of April, the submarine encountered no enemy units. Lookouts reported occasional distant aircraft, but none altered course toward the submarine. Radar contacts were limited to weather returns and indistinct surface echoes at extreme range that did not develop into identifiable targets. The absence of engagements was documented in the patrol narrative as a continuation of routine operations without significant incident. On April 17, 1943, the submarine conducted a scheduled systems inspection. This included testing of ballast tank vents and blow systems, verification of depth gauge accuracy, and inspection of control surfaces. The torpedo fire control equipment was checked and recalibrated as necessary, using drill procedures without actual firing. These actions were consistent with maintaining combat readiness during periods without contact. By April 18, the patrol record indicates continued absence of enemy activity. Fuel and battery status remained within planned parameters, and no mechanical deficiencies were reported. The commanding officer maintained adherence to patrol orders, with no independent deviations recorded. The documented narrative for this phase concludes with routine entries noting position, course, speed, and weather conditions, and with no further recorded engagements or sightings during the specified period. The available archival record does not contain additional data regarding enemy contact or operational changes for USS Tunney beyond these entries within the defined timeframe.